Good. So my name is Nathan Moore. I've been in the CDN business for a little while. My card actually now says StackPath instead of Mac CDN. This particular talk, I'll mention that in just a sec. This particular talk obviously is about getting Varnish to scale up to about 1 million different vHosts. And I wasn't Mac CDN until very recently. We were purchased by StackPath, and we're very excited because we just came out of stealth mode about a week and a half ago with a secure CDN project, which combines a WAF along with encryption everywhere and a lot of SSL optimizations and the like. So brand new, just came out, and this was multiple companies sort of put together to create a new one. However, when we were at Mac CDN is when we first worked with Varnish in order to solve the problem that I'm going to talk about today, and it does it very well. When I was asked to give this, I wasn't quite too sure what the audience was going to look like. Based on the questions earlier and sort of just gauging everyone here, I'm assuming that everyone here is sufficiently technical. I can probably just ignore the very basic stuff and just hop straight into the fun stuff. So the punchline for this particular slide is that HTTP is defined to be idempotent over the GET method. And since you're all technical, you don't need to know anymore. So obviously a CDN itself is a big, gigantic global web proxy, right? It's not just, I don't just have one proxy server somewhere. I have, in my case, I know 25 odd pops scattered around the world, so I've got literally hundreds and hundreds of servers. And one of the ideas is that I can take advantage of the bandwidth delay problem, right? Normally under TCP, bandwidth delay is an absolute killer because you're not allowed to, you have to always acknowledge that you've sent some data. And the longer that latency is before you can acknowledge it, the more that data has to sit in flight, and the longer that server has to wait before it can acknowledge, yes, I have this, I'm good, and what I have is what I think it is supposed to be. So to that end, I've got these lovely POPs around the world. The obvious example here is that we're here in LA. Well, I have servers out in CoreSite just like everybody else, right? So if you go to the website right now, guess where I'm taking you? Well, I'm routing you to downtown LA and you're getting served. We're maybe a millisecond away, maybe 2. So if you are a customer whose origin is in, say, Dallas, which is, 40, 50 milliseconds away from here, well, now I can shave the time to serve you down. I can shave down that bandwidth delay because I'm only a millisecond away. I'm not 40, 50 milliseconds away. And equivalently, if we were in New York, well, guess what? I also have servers in New York who are employing the exact same trick. So we're not just a global web proxy. We're also a caching global web proxy, obviously. This is why we are very interested in products like Varnish in order to do this. So you can see, and it's pretty trivial, right? And it's nicely, easily color-coded that if you are lucky enough to get a cache hit, I've served you in milliseconds. If you're unlucky enough to get a cache miss, well then I'm stuck. I have to go back to the origin server, fetch the thing, and bring it out. Which is why persistence is of interest. So, great, so we get the idea. I've got all these servers worldwide. They're fronting a bunch of origin servers, and I'm always very interested in my cache hit ratio. I want to make sure I'm serving globally. So I have a really big problem now because if I have 1 million customers, all those servers in the edge now have to act as a proxy for those 1 million customers, right? So now they have a horrible state problem that they have to worry about because they have to make sure that they're routing correctly. So that's what we really have, is we have an HTTP object routing problem. The request comes in, we have to evaluate it in milliseconds or less. We have to determine where is it supposed to go. Do we have it locally? Can we serve it straight out of cache? We're fast, great, close the connection, we're done. Or are we in the terrible case where we're in a cache miss? And I could be talking to who knows how many backend servers. So we have a routing problem. So in classical VCL and standard Varnish, how do you deal with this? Well, Varnish is lovely because it sets up this very obvious pipeline in how it accepts an HTTP response and it processes it, right? And that's kind of the whole point of VCL is it directly tells you, what do I do when I receive it? What do I do at the end of it? How do I process this thing? And the problem is if we're going to start making decisions off of some HTTP property, like the host header, which is what you would do for a vHost, then I have to have these lovely if-then statements, right? Because I have to check. If your vHost is foo, make sure you go to the foo origin. If your vHost is bar, make sure you go to the bar origin. And obviously, if I'm going to do this 1 million times, this means I have 1 million if-then statements. Not exactly practical. So this was sort of the problem that we sat down with Varnish a little while ago. It says, okay, well, this is kind of what we got to do. So when we were talking about this, we started doing some benchmarking work, and we said, okay, well, what's the practical limit? What can we actually do? What can we reasonably expect? And oddly enough, one of the immediate benchmarking problems was that if you have too many if-then statements, if your VCL gets a little bit too large, well, VCL has to recompile this, right? If you hit reload, what does it do? It takes VCL, compiles it, and then inserts it. It has a timeout. So if your VCL is so complex that it takes longer than this timeout period in order to compile, too bad, too sad, it never gets loaded, you never actually reload. Well, that's kind of a killer if I'm trying to dynamically add new vhosts into my global CDN system. So that was a little bit of a surprise, but it did pop up. So I wanted to demonstrate this, and so I have a quick note on this particular benchmark. This ran on my local MacBook Air in a VM with only one CPU assigned to it. And this was done deliberately because what I'm really trying to do is show what the latencies actually look like when you start playing with this stuff, right? When you start playing with the VCL. I wanted to show what that latency looks like. So fine, this is just real quick, directly to origin. I have a nice little Nginx running on there locally. If I talk to it directly from this vhost, or sorry, it's directly from this VM directly to the VM, then it takes maybe 40 microseconds in order to respond with a simple 100-byte object, right? Deliberately stupid, simple, deliberately. And for the record, I'm using H2Load as part of the NGHTTP2 project. If you've played with any of that stuff, it's a very, very simple benchmark. All it's doing is making 50,000 requests for the exact same object to this one particular URL, and it's doing it with one connection. So this is obviously with key-wise. So in this VM, again, comically and deliberately constricted, at first I was going to try 10,000 if-then statements, and of course I hit the reload timeout. So I dropped it down to 5,000. I still hit the reload timeout, but 2,500 I was able to get it to compile and insert. And so I ran the exact same benchmark, and it took on average about 221 microseconds instead of the 40 we had talking directly to the origin. So you're talking rough factor of 5 worse latency to serve an object if I'm stuck asking Varnish to do all this tremendous amount. Obviously, I'm asking the degenerate case, right? I'm asking for the guy at the very end of that list to make sure that I have to parse through every single one before you get to it. But that's kind of the point, is I'm trying to show off that there really is a cost associated with this, and it's a cost that, it winds up being pretty big. So if I can shrink the number of if-then statements down to some reasonable number like 3, then I get basically the same speed as I get talking directly to the origin. No horrible surprise, right? This is exactly what we would expect. So we can show that this absolutely is caused by that tremendous number of if-then statements. So how do you solve this particular problem? And actually, I have to give many thanks to Reza, who I have to call out publicly for having been the gentleman who wrote vmod kvstore. He did a fine, fine job of it. What it does, very simple, it's just a hash, right? You pass in the key, you get a value back. So it's an in-memory hash, it's very, very fast. And more importantly, is we get this guy to scale up to 1 million different vhosts. We can shove 1 million objects in that kvstore, no problem. And it's all evaluated in real time, and because it's a hash, it's a constant order lookup. So it's very, very fast, no matter how many objects we shove into that. So we no longer have this weird problem. So we can convert, we don't need if-then statements, and that looks something like this. Right. All I have to do is, pull out using the host header, which is why the key is the rec.http.host, because that's a host header. And what it returns back is the associated, it's a string, right? The string is the associated backend name. If I don't have that key present in the kvstore, then it returns the default, which is why the default string is there. So that's just in case it's not there, return the default. But now all I have to do is check for that. So if this is my backend, I set the back intent and I'm done, right? So now everything's like an if-else statement. It's no longer if and if. So here I actually was able to load just 20,000 vhosts, exact same environment, exact same test, and all of a sudden I'm back down to 47 microseconds. So it works. Right. Previously we were at 220 odd, and with 3 we were at like 44. So we're right in the ballpark. The thing actually does what it's supposed to do. If you start playing with it, it's got the usual getters and setters like you would expect. You can define multiple kvstores. It's done by a little integer, so you just pass in a unique number for that. So I can have pretty much as many as I like up to my memory constraints. you have funding about little setters, right? So in addition to getters, you have setters. So you're not just fetching out of it, you can also punch into it. And one of the fun things is it includes time to live. Right? So your use cases for this start really expanding, because now with the time to live, that means I have temporal content contained within this cache, right? Because I'm guaranteed if it's not there, I return the default value, right? So if it's only in there for the time that I have defined up to the TTL, well, this becomes real interesting, and you can immediately start seeing things like the earlier presentation where we're talking about, well, we wanted to authorize this key, this cookie, for 30 seconds or 1 minute or whatever. Well, this would be a really trivial way to do that. You just shove that into the KV store, right? And you're guaranteed it's gone within 60 seconds, and you're going to get the default back, so you get the default, but if be denied, and you're done. So it's surprisingly useful, and it pops up in a lot of fun little places. So how do you initialize it? You can do a bulk create, so you just have it read out of a nice little CSV file. You can pick whatever the delimiter you like. You define it's a hash. You get it, play with the number of buckets that are assigned to the hash to minimize the number of conflicts, right? The number of times that you have the different things mapped to the exact same bucket number. So that's really, really straightforward. And so this is just a simple CSV pair. Done. One of the fun things about the setter method is that it allows dynamic updating. So after we've initialized it, we've read it in from our flat file. If we want to add in something new, well, there's no problem. Right? Just go ahead and use the set. So the use case I have specifically for this, and again, I have to warn, I'm assuming you have your ACL set up so this isn't publicly accessible, you have it locked down, so not just anybody can dynamically update your lone KV store. But to do that is really trivial, right? All I have to do is, assuming that I have a little GET request with a custom header set, in my case, value add to KV store. If that header is set, go ahead and add it on in, with, of course, the value associated with that add to KV store being the value that I'm going to shove in to the KV store. Done. Oh, I guess I should point out that here in the example, I have a 0 for time to live. 0 means it lives forever. So there's a lot of other places you can apply this besides doing our host header lookup, which is the primary use for this. You can, so long as your key space is unique, this is no problem. You can map multiple aliases to a vhost, for instance. That's one of the immediate use cases. And I can do it within the same KV store because, again, the key is unique. So long as my key is unique, I can do it. So you change the workflow now. Now all you have to do is you have the host name to the vhost mapping, right? That's mapping 1. Mapping 2 would be then the vhost to the actual backend end, right? So this makes the logic really, really easy, because now all I have to do is first fetch the vhost and then do a second fetch based on what the return value of what the vhost is supposed to be, and it all pops out. All right? Again, because my key space is unique, I don't even have to use a second KV store to do it. I just use one. Another fun one would be overriding caching time on a per vhost basis. And it's a modification of the previous trick, but now all of a sudden I'm taking advantage of the TTLs, because I'm guaranteed that after the TTL expires, it's gone from the KV store. If it's gone from the KV store, I just return the default value, and I just make a decision based off of that. So in this particular case, my example is just that, well, if you belong to www.foo.com, I'm only going to cache you for 30 seconds, but if you don't, then I'm going to cache you for 3,600 seconds. So I'm going to keep you running for an hour. Easy. So one of the goals of this is VCL is incredibly flexible. It allows you to do so much, and it allows you to figure out, make all kinds of even dynamic changes now. You can actually change this thing at runtime as you're moving on based on what the values are that you asked your logic to evaluate. So it makes building out these sort of global infrastructure scale projects a lot more fun. And it's a lot easier to do now, because you don't have to, once you understand the workflow, once you understand the pipeline, then being able to make decisions along any part of that pipeline and do it within microseconds, that's a wonderful, wonderful thing. So it allows us to offer very, very highly performant solutions. All right, so that's pretty much it for the scope of this one. Go ahead and open the floor. Any particular questions? Yes, sir.
Hi. Do you not still then have a lot of if-else statements for each of the origins there where you're doing the back-end hints?
Excellent question. I was a little worried about that. So I want to talk a little bit about, so I prepped some slides on how to partition it. So obviously, we're idempotent under the get method, so we can pass through any number of proxies unchanged. If we don't care, we can pass through them, we get the same object back. So if you're the web browser, you don't care where it came from as long as you got the right object. Which means that you can start partitioning things out. You're not stuck. You can go ahead and say, well, I want my front-end server here to know about everybody, but I don't want him to route to every possible backend. Instead, I'm going to predefine a couple of backends here. And for example, I take vhost 1 through 100, send him to backend number 1. vhost 101 through 200, I send him to the second one. So partitioning this out is pretty trivial. You can go as deep as you like, and you can go as wide as you like. So it comes down to your specific use case. For me, I have a very specialized use case because one of the things that we've done at StackPath is, yes, we have 25 odd pops right now. But the way we chose to implement our WAF, we intend to protect the customer's origin, and that means that we always want him protected from the effects of the entire CDN, the entire edge. So we deliberately funnel all of the WAF requests through one particular POP, and we let the customer choose. So in theory, at least, if the customer is smart, he's picking the gateway POP that is physically closest to his origin. And then we funnel every single edge request through that one particular POP before it gets to his origin. So we can apply firewall rules. Do we want to allow this, disallow this? Are we getting an unexpected surge of requests which shouldn't be there? So someone's trying to use our CDN as an attack platform or use it as an amplification attack. And that means, going back to the previous one, that when I see requests for this guy, now I know where to forward him. Again, it's a routing problem. I want to forward him onto his appropriate gateway POP. So I actually have a very reduced set of if then else. I have this many to one relationship going on between the vhosts and where it is I'm going to shovel them, instead of having to do a one-to-one mapping of vhost to backend server.
Okay. Do you think it would be useful to have a direct map?
Yes, absolutely, it would. No question. That would change how I would choose to do things. Because of the lack of direct map, this wound up being an okay thing from my perspective for my current solution, but as I scale, as I get bigger, as the number of vhosts, what am I going to do when I have 10 million vhosts? And all of a sudden at that point, then I really have to start looking at these sort of closer to one-to-one mappings than the many-to-one mappings I can currently get away with.
Because we can probably do that though with time, because we're spinning up new vmods dynamically. And then the unused vmods will just not exist until they're actually looked up.
Sure.
And then if we could just keep like 100,000 of them around on the server, the rest will just, that should be possible.
That would be of tremendous interest. I'll tell you right now that in our future architectures that we're looking at, that we're evaluating, that we'll be in within 1 to 2 years, is we're trying to move into a much more dynamic world rather than a static world. So the ability to do things like this, call them up dynamically, and change out our partitioning scheme. So I can define 5 servers. You deal with this guy, you deal with that guy, you deal with that guy. You know, that gives me a very, very nice level of granularity to be able to solve.
Yeah, we can probably do that.
Yes, sir.
So does all the CDN traffic for StackPath go through the WAF, or do you separate it where some goes through the WAF and some doesn't?
Customer chooses. So we can support it. We can force you into the situation where all of your traffic flows through the WAF. We can do short-term dynamic caching, so that way you're always in the local edge server. So if you define a caching policy, we respect that, and we make sure that we keep it cached at the local POP. But if you want any requests through the origin, you can force that through the WAF. Or we can force it directly to the origin if that's what you do.
Is there a latency penalty when it goes through the WAF?
Yes, absolutely. So this is unfortunately true of all WAFs because they have to get the entire request, process their list of rules against that request as to whether to allow it on or not. And unfortunately, that does take time. So yes. I would comment that the nature of these things is you have to remember there are keep-alive connections everywhere. And so you want a very large amount of traffic flowing through the system because then we're guaranteed we have an existing keep alive, so at least the overhead of the TCP connection, and for that matter, the HTTP connection itself largely goes away because we have an existing one to reuse. So this is definitely something that the hotter it runs, the faster it runs. So if you're going to enable the WAF, make sure you have enough traffic to justify it, is what I'm saying.
Last question, so
Yes, sir.
is your WAF and CDN fully integrated now? Since
Oh, yes, absolutely. As of a week and a half ago, that's correct. So
that's
if you,
pretty quick, you just
Well-
acquired all these entities and that was that.
it was a lot of work.
Okay. Wow.
But yes, we're on all new equipment, we are on all new POPs, we're on brand new WAF, we've got brand new pretty much, we're global, so we're present in Asia, US, Europe. And we're talking about, we'll have Brazil very soon, and we're expanding very, very. Awesome. Yes, sir, please.
When you have these hierarchies of caches, how do you architect your TTLs and figure out your worst case scenario, and how does all that work?
Fantastic question. I'm actually really happy that you asked that. So you have a couple choices. By default, the way HTTP works, the normal proxying, and there's a couple RFCs about this, is you're trying to respect the cache control headers that the origin provides to you. You always want to respect that as to how long you should keep it around. As a practical matter, that's not possible, right? Someone's going to tell you, please keep this content for a year. It gets used once. Why are you keeping it around? Why are you paying for that? And so you're absolutely right. We've come up with a set of reasonable heuristics in order to deal with this particular situation. So we'll run a very, very short-term hot cache at the actual edge. And so Varnish's in-memory cache, I did a tremendous amount of benchmarking work for this. It's fast. It's very, very fast. The problem is Little's law. So the what is it? The size of a queue is equal to the incoming rate of requests into the queue multiplied by the time spent in the queue. So what you want to do is, if I can cap and limit the time spent in the queue, I by default am going to limit the size of the queue. So if I force this to be like a 30-second timeout, that now limits the size that the queue can possibly get, and therefore I don't need memory. And now I can drive, okay, if I know I'm becoming memory starved on these, all I have to do is switch the cache time all the way down like this, and all of a sudden I've freed up large amounts of memory, because my queues get smaller. And equivalently, the smaller the queue is, the faster I can process it. And that's the other reason for this would be this allows these guys a very, very large amount of speed, because I never have that much in the queue to serve in the first place. So that means other hosts in the chain, in the proxy chain, now all of a sudden do care about hanging on to content for very long times. So yes, I've got a hot cache, but then I need a warm cache over here. And in this particular case, with my Origin Shield product, I also have a colder cache. So I can send you through potentially 3 or 4 different servers, each with a different tiered caching policy, depending upon which will automatically and dynamically figure out, based on its aging time, how frequently used this particular content is, how hot it actually needs to be. Excellent question. Yes, or anything else?